Hello, this is Blake Cooper, and this is my video demonstration for the ecen 240 final project, creating a CPU. So I'm going to display my output and then explain how it works. So right here is my ASCII screen. I'm going to turn on tick speed, and it's going to start printing my name, Blake Cooper. And then it prints my lucky number, and then it performs 4 plus 2. It uses the ALU to calculate 6, then 4 times 2 uses the ALU to calculate 8, then 4 minus 2, it uses software subtraction to calculate the 2, and then it does 4 minus 2 one more time and uses hardware subtraction to calculate 2. This is the entire project. I have the counter, the program ROM, which basically is the code that translates the ARM assembly code into telling the CPU what to do. And then I have the decoder ROM, which basically translates ARM assembly code into allowing the CPU to function and utilize all of the things that it has, like the register file and the ALU. And then I have two subcircuits, register file and ALU. Here's my register file. It has a demultiplexer and then two multiplexers on the output. And then my ALU has an A line and a B line. And it also has a subtraction bit, so that when this bit is high, it will perform subtraction. And then it also has this select bit for selecting between XOR and OR and add. Going back to my main file, the way that this CPU is able to print characters is that you move a hexadecimal number into a register, and then you use the display function to display the value of two registers together. So for example, the first letter of my name is B, and the way that is displayed in ASCII is by loading a 4 into register 1 and a 2 into register 2, and then you display 4, 2, which is ASCII right here for B. And then going along with that, I mentioned earlier that this program uses software subtraction and hardware subtraction. So this is the ARM assembly code that my PROM is running off of, and it does the software subtraction with this. So you use XOR to flip the bits, and then you add 1. And so when you take the 2's complement and the 1's complement, you're essentially making a number negative. And so then you have that negative number and you add it to the other number. So this is a software subtraction using XOR and adding 1. And then I also have a hardware subtraction, which uses the sub command, which comes from my ALU. So essentially, the ALU is basically doing the same thing where you flip the bits and you add 1. It's just hard coded into the program, so you can save steps in the ARM assembly programming. But yeah, that's basically my microprocessor and it working to add, multiply, subtract 2 different ways, and also to print the ASCII numbers.